Now we're going to look at using technology, which means graphics calculator in our case, to solve these equations. We'll go down these hard ones, 1e4, 2. Now I'll do the first one. So we got x plus 2, x take 1, and equals 2 minus 3x. So we've got x plus 2 times x take 1 equals 2 minus 3x. Now if we want to solve that manually, we'd just put everything on the left hand side and make it equal to 0. We'd FOIL this first, so firsts, outers, inners, last. Outers and inners is going to give plus x, and the last is minus 2. Now we take that onto the left hand side, so plus 3x, so we get 4x, and you subtract 2, so it would be minus 4. Now factorising this, we'll get that to be 2 times 2, and there's we actually can't get plus 4, so we'd have to use something different like completing the square, or we could use the quadratic formula to get our answers. Alternatively, we could go to the graphics calculator, and that's what the question is: use technology. Don't use the quadratic formula, don't use completion of square, although we could do that. So to go to the calculator, we could do two things with the way we interpret this. This is really saying that this is a quadratic on the left. When is that quadratic equal to this linear function? So if we were to sketch that, we've got the quadratic passing through minus 2 and passing through 1. So we have a quadratic looking like this. We've also got a linear function, minus 3x plus 2, y equals mx plus c. So it cuts at 2 and it has a slope of minus 3. So that comes down like this. And we're interested in where it intersects. And we can see that the answer is this value here. We want to know what that value is. Where do they intersect? We've actually rearranged this equation into another equation, so the answer to that is exactly the same as the answer to this. Now this one here is a quadratic, and we know the answer to that is when does that quadratic equal 0, so it's asking for the x-intercepts. So this could be a quadratic like that, and the solution will be exactly the same as this one here. So we can do it either way. We'll do it both ways on the graphics now. Now I've put the two types. I've done the first two functions and then the rearranged in the third in the y equals in the graphics calculator. Let's do the first method, that's intersecting these two, y1 and y2. So I'll highlight these two and plot them and intersect them. And now I'll press graph or zoom fit. There's the quadratic coming down. Our linear is going to come through soon. And notice there are actually two answers, one up the top left and one down the bottom right. So to intersect it, we go second calc, intersect 5, and you go to ask for the first curve, the second curve, and a guess, and the answer is 0.82. If we do that again, second calc, intersect, and we go first curve, second curve, but this time we're going to move it closer to the other point for our guess. It'll give us the second value, the second answer, and we press enter. We get minus 4.8. Now doing it the other way, the other method, we rearrange these two into the quadratic sitting in y3. So it should give the same answer for the zeros of y3. So if I highlight that one and press graph, and we can see that the solutions to this look like going to be the same. To test it out, we go second calc, but this time we're doing the 0, 2, and we go to the left, and then we go to the right of that point. Press enter, and there's guess, and you can see that's 0.82. If we could do the same over on the left, we get the same answer. Okay, so that's how you will do the questions in question 2. So this is using technology to try and do this. I've done A, you try B to F. And here are the answers. Question 2, we did -4.8 and 0.82. There's B to F sitting there.